Okay. So in the last class, we started with creating VMs under the virtual networks in order to test the inter-site connectivity between the machines. So what we did, we created one machine, core services VM, then we create into one VNet, like core services VNet, then we created another VM, manufacturing VM inside manufacturing VNet. There were two subnets, core subnet and manufacturing subnet. So let me share the old diagram only where we already worked on that. Okay. So what we did, we created a core services VM inside the core subnet, which was inside the core services VNet. Then we created a manufacturing VNet, VM inside the manufacturing subnet, which was under the manufacturing VNet. Now I was explaining you the connectivity, how, what type of connectivities exist and how we can perform that. So generally, if organizations trust Azure connectivity, then they can go with the Azure connectivity. Now, what does Azure connectivity says? That create a peering link between the virtual networks. So this is the peering link. We call them it as a VNet peering link. But when we allow VNet peering link, that means all the subnets within this VNet will go and connect to all the subnets inside this another VNet, manufacturing VNet. So with one peering link, all the subnets can connect to each other. But generally in organizations, there are different subnets and organization do not want that each subnet should connect to each subnet on other VNet. So what they do, they come up with firewall. So they set up a firewall in the VNet. Now, generally, when we set up a firewall, what it will do, it will block the peering. It will block the peering. It will not allow that Azure connectivity. So then you have to go with what? You have to go with the traditional method. Now, what does traditional method say? That add a NSG to the subnet. So here we added one NSG, here we added another NSG. And what we did, we configured the rules in the NSG. What rules? Inbound and outbound rules. So if the traffic is going this way, then you have to configure an outbound rule here. And since for this side it is inbound, so you have to configure inbound rules over here. Similar way, if the traffic is going outside this way, here you have to configure outbound rules for the outbound traffic. And since the traffic is coming this way inside, then you have to configure inbound rules. So as per the requirement, you have to configure. If you want bidirectional traffic, if you want traffic, you have to set like this. But if the need is of only unidirectional, means from this to this, VNet 1 to VNet 2, then you will set only one type of rule. Like this side you will set outbound, this side you will set inbound. Okay. So like this is what traditional method of connectivity. So generally, you will not find in labs designed by Azure, you will not find other type of connectivity. Okay, this type of custom method of VNet integration you will not find. Okay, you will only find Azure connectivity, that is peering link. But generally in organization, peering will be blocked. Okay, so you have to follow this method for connectivity. You have to attach the NSG and then you have to allow the traffic. Okay. So this was the method we discussed in the last class. Now let's try that connectivity here. So for that purpose only what we did, we created one VM inside one VNet and another VM inside another VNet. So we have two VMs with us. So in the last class, what I did, I stopped the VMs. Okay. So what I'll do now, I'll start it. Once the VM is started, we'll try with the connectivity between the VMs. Started. See other VM as well. Okay, this is also started. Now let's go to the network watcher service. I'll go to network watcher. And first I'll go to inside the diagnostic tools, I'll go to connection troubleshoot. Source type virtual machine. Which virtual machine? From core services VM. We are trying to connect another virtual machine, that is manufacturing VM. Both IP protocols will be taken into consideration. Destination port will be 3389. It's an RDP port. Source port, leave it. Run the diagnostic test. If you do not want to try with the network watcher, you can directly go to the VM and ping. You can ping one VM from other. Take the VM IP, ping it from one VM. If you are able to reach to other VM. Okay, that is other way. Actually, network watcher is a service in Azure which you can use for any type of troubleshooting, network troubleshooting related to network. Okay, tests are completed and it is saying that connectivity is unreachable. Okay, connectivity is unreachable. Outbound NSG denied. Okay, so NSG is not allowing the connectivity. Now, first method. Okay, Azure method. What it says? create a pairing link between the VNets. So let's go to the VNet. Let's go to the core services VNet. Go to core services VNet. See, as of now, you can see firewall is not configured. Generally, firewall will be configured in organizations. Okay. As of now, firewall is not configured. So Azure connectivity will work here. Okay. So in the networking here, in the settings, you can see peering. There's an option called peering. Click on add. Give a link name. So core services VNet to manufacturing VNet. Mm. Subscription, choose the virtual network. Allow manufacturing VNet to access core services VNet. Allow manufacturing VNet to receive forwarded traffic from core services VNet. This will be selected by default. You have to select this one. And the other one will be manufacturing VNet to core services VNet. Select. So both way traffic will be initiated. Okay. So from core services VNet only you can establish on both the VNet. Add. So two peering links are being created. One from core services VNet to manufacturing VNet, another one from manufacturing VNet to core services VNet. Go to manufacturing VNet, go to peerings. This is the second one. Check the peering status. Peering status connected. Okay. I think we connected reverse, like it should be core services to manufacturing VNet. Wait. Okay. Core services VNet to manufacturing VNet, and here it is manufacturing VNet to core services VNet. Okay, let me go to core services VM, copy the private IP address 10.0.0.4, go back to manufacturing VM. And from manufacturing VM, operations, I'll try to run a command. Test hyphen net connection 10.0.0.4, port 3389. Okay. TCP test connection succeeded. That is true. That means VM is reachable. From manufacturing VM, we can connect core services VM. So this is a, you can see it's a direct connectivity like we have shown here in the Azure method. Okay. Now let's try a indirect method as well. like creating our custom routes. Now, there are two things. When we are trying Azure connectivity, method, so it is following Azure routes. Azure routes means one VM is directly connecting to other through peering. Azure routes. What if organization wants to define their own routes? So if organization wants to define their own routes, then they will go with what? Custom routes. Custom routes. So going with the custom routes, what we will be doing here, we'll go to core services VNet, go to subnet. So one subnet is already created where the virtual machine is present. I'll create another subnet here. Let me name it perimeter, for example. Okay. Address range will take 10.01/24. Add. Now this is perimeter subnet. We'll go for route tables. Route tables. So as of now, what was happening is there is a direct connectivity from this VM to this VM. A direct route followed. So this was your core VM and this was your manufacturing VM. And a direct route is followed here. Direct route. And how does the direct route followed? Through peering. Okay. And what we did in peering? So we gave an address of this VNet to this VNet, and we gave an address of this VNet to this VNet. So in this way, a peering is created like this. But what if I don't have to follow the direct route? Suppose this VM is there. Suppose this VM is there. And there is this VM. I don't want to follow the direct route. I want to connectivity to be established by a third VM. So means like first I should go to this. First I should go to this VM. And from here, this VM will connect me to this VM. This VM will route the traffic to this VM. So now, what is this VM for me? What is this VM for me? So this becomes a router for me, router VM. Okay. Generally, we call it as a NVA. NVA is what? Network Virtual Appliance. NVA. A VM converted to a router. So by running some commands, we can convert a VM to a router. Okay. So in that case, this was the VM1. This was the VM2. And we are routed to VM2 via another VM, which is a router VM. This is a what? NVA. Okay. Network Virtual Appliance. So this is a custom defined route. We created a VM, a network VM, on which we have a total control. That organization is having a total control over this VM. So we can manage this VM anyhow. Like how do we want to manage? We can manage this VM. So in this way, we are managing the traffic also. Whatever traffic I want to let in, or whatever traffic I want to route to this VM, whatever traffic I want to block, I can do anything using this VM. So generally, what do I trust here? I trust NSG here. NSG to NSG. Here also there is NSG, here also NSG. I'm trusting. Since Azure trusts their own NSG, but organizations do not trust that also. So what they bring in? They bring in a third VM, okay, where they are configuring their own rules into this machine, network virtual appliance. And this machine will allow or deny the traffic to this machine. Okay. And in general, NSGs are already set. Then also, it's what do we call this? This is known as add-on security. Okay. So NSGs are already there, but still, this is an add-on security. NVA. So we call this as a custom route method. Okay. So we'll create a route table here. Give the name as RT route table for core services. Propagate the gateway routes. No, we don't need any gateway routes as of now. Next, next. Go to the route. Is the route created? Go to route. Go to settings and add the route. Give a name to the route. perimeter to core. Destination type IP address. So take the IP address of the core services virtual network. Next hop type is I want to go through a virtual appliance. Means I've created a VM which I'll be converted into a virtual appliance. And next hop address, let's say that virtual appliance, that virtual machine address is 10.0.1.7, like this. After adding this route, we have to configure the subnet as well to the route. So associate a subnet. So in the core services VNet, we will associate core subnet. So now this route is associated to core subnet. Now, instead of traffic directly going to the manufacturing, it will route through the perimeter subnet. Okay. So we created a subnet in the VNet, extra subnet, and that was perimeter subnet in which my network appliance is there, network virtual appliance. So this subnet is a perimeter subnet, perimeter subnet. This subnet is a perimeter subnet. This subnet was the core subnet inside which the VM I created. So what was the IP of this VM here? It was like 10.0.0.4. And this was something 172.16.0.4. So now it will route from here. So maybe my machine, which I'll be creating inside perimeter subnet, since the perimeter subnet IP is 10.0.1 slash 24. Dot 0. Huh. 10.0.1.0 slash 24. This is the range of my perimeter subnet. Okay. So out of this, this is my machine which can have some IP 10.0.1.7. Some future machine which I can create inside perimeter subnet. And now my traffic will go from 10.0.04, that means core, to perimeter machine. So this perimeter machine is what? It's a virtual appliance and it will route the traffic to the next one, like we created here in the route. So this is the route. So route says that destination is IP address. What IP address? The virtual IP address of the core services VNet. Where it will go? It will go to the virtual appliance. Where the virtual appliance is located in the perimeter subnet. Okay. So from there it will route the traffic. So what is this? This is my user defined route. I am not using an Azure route. I am defining my own route. Now we'll see how to manage the traffic management basically. Route is clear. What is an Azure route? What is a custom route? Everyone.
Yes, Abhishek.
Okay. Now let's see the traffic management.
So, Abhishek, this is Bhagesh.
Mm-hmm.
So, on a custom route scenario,
Mm-hmm.
there is no role of firewall, right? As of now.
No, there will be firewall.
So,
This is an custom security we are pitching in using the
that
custom
is,
route.
that is correct, but that is not the typical firewall appliance that you're gonna deploy, right, to establish that connectivity.
Where in this parameter sub,
Yes, yes,
see, parameter, we deployed this into, see, where is the firewall? Firewall be deployed in the VNet. Okay. We deploy firewall in the VNet level. Okay. This is the core VNet.
mm-hmm.
This is the core VNet. Core VNet. And the other one was the different VNet here, where the traffic was going. Now,
No, that is,
earlier
yeah,
it was making use of peering.
okay, that is clear.
Okay. Now, when
Uh,
we are selecting custom route, that means we are indulging like, or you can say we are creating one more, uh, you can say a parameter subnet here in the same.
Correct. I
This,
hope, yeah, in between.
now, generally, whenever we do this, that means core means suppose you assume that my core services are running in my core VM, in my core
Hmm,
subnet.
hmm,
So generally, I will not allow my this VM to be directly connected to the network.
correct.
So what I'll do, I'll apply a hop
Hmm,
method. Means
correct,
the traffic will hop through this parameter VM or network
correct,
virtual appliance. Now this
correct,
virtual appliance is connected with the network,
correct.
but this is not.
No, I get that. My question is
Mm-hmm.
from the appliance point of view, right? In traditional way,
Mm-hmm.
we generally having the firewall where
Mm-hmm.
we generally, allowing and denying the custom rules based upon the requirement.
Correct.
Just similarly, the IP route, what we are defined as a next hop, right?
Yes, yes.
My question is, in this scenario, we have not deployed the typical Azure firewall as a appliance. We
Mm-hmm.
have used the Azure router, right?
Yes, yes,
Router VM as
yes.
a firewall. So
Mm-hmm.
it will be act as a firewall, but it is not the firewall.
Yes, it will act as a
Remain there.
firewall, but it is not a
Yeah,
firewall. You are correct.
exactly, exactly.
Yeah.
Okay.
So Abhishek, means you mean to say like we can apply separate firewall also means two options are there.
Means whatever Bhagyesh said that this will act as a firewall, but it's not really a firewall. Okay. So what
Okay.
you are doing in case you are applying your own firewall, your own type of firewall by applying a network virtual appliance. Generally, why does organization do this? Because in general, they will say, no, no, I don't trust you. So they will say, Azure, though, I am not trusting you. I will make my own configuration. I'll set up my own machine, virtual appliance over there. Okay. To stop or allow the traffic, to deny or allow the traffic.
And
Okay.
in additional layer of security, we generally propose to have the separate NSG rule prior to route the traffic through the route table.
Yes. Now, let's see traffic management. So,
Abhishek, a quick question.
mhm,
On the previous scenario, if I specified a custom rule
mhm,
at NSG level,
mhm,
okay, that the manufacturing VM and the core service VM has a custom rule as
mhm,
the NSG level, and
mhm,
it is denying that traffic what we allowed in router. Okay,
mhm.
so it will be block that traffic even though it is the route table has been created, or it will be allowing traffic since it is unable on the route table. What will happen?
It will take the priority whatever is set in the route table.
So you mean if I block the traffic at NSG level,
Hmm. No,
it
no, no,
will.
no, no. It should be allowed on the NSG level also. Sorry. It should be allowed at the NSG level. See, what we are providing is double security here. Okay. So if any one of it is blocked, even you are blocking it to the NSG level also, then also it will be blocked. So both, see, for example, there should there are two, like say there are two houses in the same premises. Each of the
Hmm,
house has their own gate.
hmm,
But until and unless both the gates are open, there no one can go into any other house. So both the gates should be open. Though the both houses are in the same premises, but both the gates of both the houses should be open. Then only people can communicate to each other. Otherwise, any one of the gate is locked, other one is open. Though the both the houses are in the same premises, then also if one of the gate is locked, the people will not be allowed to communicate to another house people. That's what. So
okay.
both should be open. Okay. Okay. So. So now, for example, there is this, you can say, I'll take an example, any example of, say, support, there's a Netflix. Okay. Now in Netflix, there can be different categories of services Netflix is giving. Maybe like there are action movies, then there is comedy, then there is sci-fi. Then there is stand-ups, and like this, there are different, you can say, horror. Now, all these categories like this, all have different servers. All categories are running in different servers here, like this. Action movies, action movies are here. into this one. Then comedy movies into this one. This one. Stand-ups are here. Now, generally, if I do not talk about the app, here what you are searching for netflix.com. Netflix.com. But when you select any particular area, like action movies or comedy movies, how did it route the traffic? How did it manage the traffic to so many categories? Here. So there is a gateway here. There is a gateway. Okay. Generally, we call it as an application gateway. This is an application gateway. App gateway. This application gateway, here in Azure, we call it as Azure gateway, Azure application gateway. So whenever you select anything, okay, so it will resolve like this, like here, resolve into the action movies, action, or if you select comedy, comedy like this. If you select stand-ups or sci-fi, it will resolve into this server and like this, stand-ups. So generally, when you are selecting, when you go into any, you can say front end application, you go and select action and this, then behind there is an application gateway which works and directs your traffic to those servers, those particular selection, what you are doing. It will be like netflix.com/action movies. Like you go to website, you generally, if you have, I don't know if any one of you noticed. For example, in this portal, portal.azure.com, as of now, this is my home page, my dashboard. If I select anything here, so it has routed me to the route tables. Microsoft.network. Inside the network category, I'm into the route tables. Similar way, if I opt for virtual machines, I'm inside the Microsoft.compute virtual machines. I have been routed to virtual machines. So how this traffic is routing, okay? How the traffic is management has been done. So behind there is an application gateway, which helps. Now, how does this application gateway works? So what we need to configure is a backend pool. So if we talk here, I have two servers. This is one machine and this is another machine. Why my one machine is in subnet 1, subnet 1. Another machine is in subnet 2. VM1, VM2. And here I created a backend pool where it will decide where to route the traffic. This is my backend pool. Backend pool. Now, suppose People are accessing. People are accessing. And either the traffic will be routed this way or either the traffic will be routed this way. Suppose there are some people want to go and watch the images. So there is this server VM1, and people want to watch the videos. This is another server. So there is a backend pool where I'll configure all these things. And generally, this is my load balancer here. Load balancer. Users. So now this load balancer, what is load balancer? Load balancer is nothing but generally a web server only. Okay. So this load balancer is having a front end IP, public IP. Okay. Generally public IP. So users will not directly go to these servers. User will go to the front end. Suppose this Netflix acts as a front end. Users are coming to this. And they are routed using the application gateway or load balancer or load balancer. Now again understand application gateway, this is a layer 7 load balancer, and load balancer is layer 4, that is network layer 4 load balancer. There is a difference between I explained the difference in the last class. What is layer 7 and layer 4? So load balancer generally works within a network. Now you can see that this is my virtual network here. And within single network, I have two subnets. So load balancer can help me route the traffic within the network. But if these servers would have been into different networks, then a load balancer will not work. Then I need what? Then I need an application gateway. Then I need an application gateway. So to route the traffic, to route the traffic or to distribute the traffic accordingly. Now, when I say accordingly means someone may have to go and watch action movies, someone may have to go and watch comedy movies. Similar way, someone may have to watch images, someone may have to watch videos. So accordingly, distribute the traffic accordingly, we use load balancers. Load balancer is a general term, and we have two types. layer 4 load balancer known as load balancer only. Okay. And second one is layer 7 load balancer known as application gateway. Application gateway. So please remember, whenever you want to distribute the traffic within a network, if your applications are residing in single network only, then you can use load balancer. But if these servers are residing in different virtual networks, different networks, then you have to use application gateway to distribute the traffic. So now we'll take an example of the load balancer. Okay. I'll take this template out.
So Abhishek, like this, load balancers are depending on the type of architecture we're following, right? Like if we have deployed our services in different networks,
Mm-hmm.
then we will go for that layer 6
Application
one, right?
gateway.
App gateway, right?
Mm-hmm. Yes.
And if it is so, one basic question, Abhishek. So, but nowadays, like for heavy traffic and scaling, all those things. So, I think organize means wherever these all streaming apps are deployed, so they might be using layer 6 only, right?
Layer 7.
Sorry, layer 7.
Yes.
Okay. So, for traffic management, we can say like it can take more load, right?
Yes. Yes.
Okay.
The application gateway, load balancer is a kind of a web server. Application is gateway is itself a server in it, like because when you deploy an application gateway, it itself take a whole subnet.
Mhm.
It itself take a whole subnet to deploy an application gateway. So that much of a powerful server it is, application gateway. It's like a server only, like a VM only. Okay.
Okay. And in layer 4, we can say like all the services are deployed in single VNet, right?
Yes.
Okay. Okay.
Just understand the term within a network and across the network.
Mhm.
So
Okay.
load balancer works within a network.
Mhm.
That is also known as network layer load balancer. And
Yes, sir.
layer 7 means application level. Okay. So application
Correct.
level can work across the network also.
Mhm.
So that's why it is known as layer 7 or application level load balancer.
Okay.
Already 9:50. I think it will take another 45 minutes to deploy. I'm thinking of doing in the next class only because it will take around 10:45 to complete.
Okay.
Okay, no issues. Do one thing whenever you practice na, once the practice is done, do delete the whole resource group. Don't keep it open. Okay.
Could you please show where how to delete that?
So this is the resource group.
Mm-hmm.
Go to resource group, delete the resource, click on delete resource group
Sure.
and delete the resource group.
Okay.
Yeah.
Hello,
Yes.
good morning, Abdul बोल रहा हूँ. Hello.
Yeah, good.
No, I think he's on a
Uh, ac-
call.
no.
Okay.
Actually, for 1 week I am in hospital, so I haven't attended any classes.
Mhm.
So I want to know the updates of DevOps. When the DevOps class will started?
See, as of now, we are into lab 6. As if you follow the schedule, we are into the lab 6. Okay. Total, there are
Okay,
11 labs. So I need somewhere around 5 classes to complete.
okay.
5 classes means you can consider 2 weeks more.
So it will include Terraform also.
After DevOps, when we complete DevOps, then we'll go to Terraform.
Okay.
So DevOps will be starting in like after 5 classes.
No, actually I am already in DevOps classes, which is in morning 7 a.m. So I missed two or
Okay.
three classes. So I'm not updated with that.
Mm-hmm.
That's why I'm asking. Because I was in hospital, so I haven't attended
Okay.
any
You are
classes.
not in the group.
No, I am in which group, sir?
7 a.m. group, community
Yeah,
group.
I am in uh
So I'll post out a message in that. Okay. As of now, the next
okay.
class is on Sunday. Okay. Sunday, 8 a.m.
Hmm. And second thing is that I always confuse between ASG and NSG. But like ASG is at level 7 or ASG is a level 4. So I'll
ASG,
always
see, application is
hmm.
layer 7. See, check OSI model. If you have seen OSI
Hmm.
model.
Yeah, I know OIC model. So
So
I confuse with the
wherever it comes application, that means layer 7.
okay.
Okay.
Layer 7. Okay. So it means application is layer 7. It means it works as a router. It is used to communicate between two different subnets, if I am right or
Two
I'm wrong.
different virtual networks.
Two with so virtual network is obviously having two different networks like one has
So
172
see, there
and
can be
one has
many subnets inside a virtual network.
okay.
Yeah. But if you want a
Hmm.
communication between two subnets which are in two different virtual networks, then load balancer will not work. Then you have to go with the application gateway. And there you have to and
Load balancer means network layer NSG.
yes.
Okay. I always confuse with these two terms.
See. NSG
Okay,
are the
920.
NSG just are the security groups where you will configure the rules for traffic.
Okay.
Okay,
It
and
means कि suppose,
load
हाँ,
balancer will distribute the traffic. Okay, and
okay,
how it will distribute the traffic following the rules. So load balancer will follow the rules which are in the NSG. Application gateway will follow the rules which are in the ASG. Got it?
okay.
Yeah.
Hmm, I forget. I have to ask more question, but I forget.
No worries. You can ping me
Ah,
on WhatsApp.
you which service is worked on VNet level?
Which service?
Uh, like ASG or NSG, which work on and in VNet level? Suppose I have a VM and I want to expose VM to outside the world, so I have to use ASG or NSG.
You have a
I
V.
have a VM,
Mhm.
and suppose I have application server or database server, and I
Mhm.
want that these
So
servers
you are saying
exposed
that
to
VM
outside the
is in another VNet and database server is in another VNet.
yes,
Ah, okay.
and I want that people come to the database server through any server which is exposed to the outside the world. We don't want any server directly exposed to the internet.
Mhm.
So at so how can I do? I do NSG. I have to expose that server to from ASG or from NSG. I think you're getting the point. If
ASG
I want to, uh, uh,
ASG is for if you are, for example, you are running any public facing application. Okay.
public system. Okay, okay, okay. Hmm,
And if you want to filter the traffic over that public facing application, front end application
hmm,
mostly. Now,
hmm.
definitely the customers will be coming from over the internet all around the world. So there you will be using always you will be using ASG only.
Okay. So suppose we are in on premises, so we use NAT and PAT. So by default, Azure is in backend they are using NatPat, or there is some other thing they are using for exposing that, uh, or it is different, something different.
See, net gateway is a different concept.
Okay, okay,
Okay.
okay, okay.
Okay.
Got it, got it.